Hi, my name is Sandeep. You are watching Knowledge Exchange where I talk about technology and I love to talk about human psychology. Today, the topic of my discussion is architecture concerns which arise when you have to implement microservices. In the previous session, we talked about what is microservice and why microservices are there. Once you define your services using design patterns like domain driven design, you have n other architectural concerns which has to be resolved to make a successful microservice architecture. So let's talk about that. In this particular example, I'm talking about a user who is accessing application from the devices like laptop, your mobile, your tablet over the internet. In the monolith world, it used to be a big fat backend application running as a single process, and it was easy to identify where to go to get the backend response. But now with the microservice architecture, the entire backend piece is split into the fine-grained services. For example, service 1 and service 2. So now the question arises, how does the front-end application will get to know what is the endpoint for the microservices to reach for? So since there are n number of microservices, rather than maintaining those information at the front layer itself, we basically get that information through the gateway. So gateway works like a front door for the front end application to access the services which are sitting behind the gateway. Now, interesting question is, how will gateway get to know what are the services available to cater to the user requirements? So in that case, the services register themselves into a platform, for example, the discovery server. Registry and discovery server is where all the microservices, whatever the running instance or the replicas are there, they get registered so that this become a one single stop of solution to get to know what are the APIs or services available. And the gateway is gonna talk up to discovery server to find out which particular service the request should route to. Okay. Now third thing is, within a service you can have n number of instance or replica of the service. How does server find out which particular instance the request should route to? For example, for microservice 1, there are two instance 1 and instance 2. How will gateway find out whether the service has to route to instance 1 or instance 2? That's where the load balancer comes into picture. Based on the applied algorithm on the load balancer, it will determine whether the request has to go to instance 1 or instance 2 or instance n. So that's the load balancer. So once the request goes to a particular instance of the microservice, and let's say that this service is dependent on another microservice for certain information, then how will microservice 1 will talk to microservice 2? So there are couple of different ways of achieving that solution. One is microservice work as a client, go back to the gateway, look for the required service, and then make a call to the respective instance from the microservice 2. Secondly, since gateway is also acting as a front door for the internet data or the internet request, there is another solution, service mesh, which is totally inside the system where service 1 will talk to service through using the service mesh implementation, which can have various variants, like for example the sidecar. So instance 1 sidecar will go and talk to the sidecar of instance 2, and that's where the handshake will happen between microservice 1 and microservice 2. So the service mesh has become pretty handy as an alternative to the gateway when it comes to service communication. Now these are the big building blocks which comes into play once the services are defined using the design patterns like domain driven design. Now Once you have applications scattered across the microservices, across registration on the discovery channel, then the gateway and service mesh, which has lot of overlap in the features. For example, at the gateway you can start with the first basic thing. When there is a certain request reaching to the server, it determines whether the user is authenticated and authorized to access one particular API. So that's the authentication and authorization. Second is caching. You can have a caching within the API. You can enable the caching at the gateway level. It depends on what sort of requirements you are handling with. But yes, gateway is another popular layer where you can enable the caching. Throttling is another feature where you want to make sure that every client basically is able to use the API, and you have a threshold limit for the end user to consume the API. It can be a number of requests which can be sent in a particular time duration, or it can be the number of concurrent users who can access the applications, who can access the APIs. Then retry. Now on the gateway, let's say that there is a first retry to the instance 1, right? And then there is a certain network issue, or there is a certain other reason because of which it got timed out. So all the retry related stuff you can basically enable in the gateway or in the service mesh. Then similarly, the circuit breaker is the one where you want to gracefully exit. So that kind of workflow also you can enable in the gateway itself. And finally, at the gateway level, you have n number of APIs available to consume. But from the end consumer perspective, how will consumer get to know what are the APIs available on the gateway? So for that, there is a popular stuff, API portal. It will be an API marketplace where all the APIs available on the gateway can be seen and can be tried with a trial version, and then you can register to access the API. So these are the different sort of key things which you handle with when you start implementing the application architecture. There can be a lot of other things, for example, on the load balancing side, whether you are going to do it on the server level or whether you are going to do it on the client side level, you have n number of different things to take care while considering the microservice architecture. Thank you. Have a good day.